Hello everyone, my name is Anton Boyko. I'm Microsoft Azure MVP from Ukraine, and today I want to talk with you about cloud-powered mobile applications with Azure. So basically today we will go into some kind of first overview. What is Azure Mobile Services about and why Azure Mobile Services are interesting for iPhone and Android developers. So when we talk about Azure Mobile Services, it's kind of mobile services is a keyword. So it's a service which is responsible for connecting our mobile devices to some backend. And what we have at this backend? The first point is storage. We have a SQL storage. To be honest, it's even like SQL Azure storage. It's a relational database, and we can store all our structured data in this database. Also, we have like built-in support right out of the box for authentication scenarios. Microsoft provide us with already pre-configured authentication for popular social networks like Facebook, like Google ID, also for Twitter, and so on and so on. And of course, if we talk about Azure Mobile Services, we also have an Azure Active Directory integration. That's why if you want to create like enterprise level mobile applications, you can easily use Azure Mobile Services because you can easily integrate it with your on-premise Active Directory. Logic. Of course, when we talk about some service, we do not need a service which performs like in total black box mode. We need to sometimes adjust the server logic, and we need an ability to somehow control what will happen for each user request. In this case, if we talk about Azure Mobile Services, we also can manage all this stuff, and we also can control what will happen per request. It's quite easily. Also, push notifications. If you are like mobile developers, you already should be familiar with push notification services. I just want to say one point that if we talk about push notifications, in Azure Mobile Services you have like two ways. Use regular SDK for different providers and use notification hub to send like extremely lot of push messages in a second. But we will talk about this later. And my favorite stuff is scheduler. You can create your own jobs and you can schedule these jobs. You can write any logic, and you can easily configure this logic, these scripts to run anytime you need. And we will also talk about this on the next slides. Let's start from structured storage. As I already said, this structured storage is powered by SQL database. If we talk about Azure Mobile Services, they use SQL Azure database as a storage. So we have like a full power of SQL Azure database, and also we have already pre-configured SDK and a lot of methods to work with this storage in object-oriented model. We also have a way to write our custom SQL scripts, but if we do not need it, if we want to work with structured storage using some kind of object methods, we can easily use it. As I said, it supports rich querying capabilities. Of course, because it's SQL Server, so we have like all power of transact SQL queries here. Another good stuff is dynamic schema. If we talk about dynamic schema, let's say that we have an application. We store, for example, user contacts, And at some point we understand that it was like one single column, one single field for example, user phone. And some contacts can have like several phone numbers, and we want to say that, okay, now we will store 2 phone numbers for each contact, and we need to create a new column in database. If we will enable dynamic schema, we can achieve it quite easily. We just need to click one button on the portal. I will show it also today. And in this case, when we will insert new record with new additional properties, Azure Mobile Services will automatically generate all required columns. It's a very good feature. And of course, if we talk about how we can manage this structured storage, we can use Azure Portal, we can use Silverlight tool provided by Microsoft on Azure Portal, we can use our kind of old and familiar SQL Management Studio, and a lot of other stuff. So basically, if we have kind of our favorite tool for working with SQL Server, it's not a problem to use this tool for working with Azure Mobile Services backend database. Now I want to talk a little bit more about REST API. If we talk about database, then basically we can perform 4 different operations on this database. It's create, read, update, and delete, of course. And if we talk about REST API, because Azure Mobile Services is like REST API, we can easily see that each action for database has its own HTTP method, like post, get, page, and delete. And if we want to access an appropriate method for our table API, we just need to send a request to https myservicename.azuremobile.net. It's like a default domain for all mobile services in Azure, /tables/ and name of our table. For example, to-do item. And that's all. So basically, you can say that each device or each platform that can send HTTP requests can work with Azure Mobile Services. And it's true. Now, if we talk a little bit about JSON to SQL type mapping, as you may know, in REST API, it's like a default standard for serialize your data. It's JSON. And when this request will come to the API will transform our JSON entity to appropriate SQL entity, and for type mapping, he will use like this approach. So each numeric type will be translated to float, Boolean will be translated to bit, date time to date time offset, and string will be translated to nvarchar max. So it's just for your information that if we talk about structured storage, we will also talk about like strong type structured storage. Now I want to say several words about auto-generated columns for all our tables in SQL Azure Storage. So of course, each entity, each row in our database should have its own ID. This ID is a primary key, it's unique GUID. Microsoft use GUID here. It's also kind of good approach because you can easily generate this GUID, for example, on a client side on your mobile device. You can easily generate this GUID on like service side, or you can easily generate this GUID on a database level. So it's absolutely no problem to use any scenario. And in case, for example, you need to create some kind of, I don't know, some kind of very strong related entities on mobile phone and then upload all those entities through Azure Mobile Services, you can easily generate these IDs and create an appropriate references on your mobile phone. And after that, you will be able to easily upload it to Azure, and it will work just out of the box. The next auto-generated field is created at and also updated at. Basically, it's like date time of entity creation and date time of entity last update. Also, Microsoft provide us with version field or version column. This column is timestamp. We can't modify this column. This column will be auto-incremented automatically at database level. And we need this column to manage two different scenarios. The first one is concurrency. Let's say that we obtain I don't know, like a single entity on 10 different devices, and after this, each of our devices start modifying this entity. And at the same time, we obtain like 10 different updates queries. In this case, you can use this version field and seek this entity in a table, not by saying like ID equal blah, blah, blah. You can also set ID equal my primary key and version equal this timestamp. In this case, after you update the first entity after you update this entity at the first time in database, this timestamp field will change. It will auto-increment, and all other queries will be rejected because there are no entity with this ID and this old version. And on mobile phone, you can easily handle this scenario and set, for example, okay, entity was changed by someone else. We need to download it again. We need to, I don't know, check, compare, maybe show some notification dialog to user, and so on and so on. And second scenario for using this timestamp is offline mode. If you have like bad internet connection, or if your users, I don't know, prefer to work offline for some reason, you can also manage this table synchronization quite easily using this timestamp. Because, as I said, this timestamp is auto-incremented, and for example, if you have like contacts table on your mobile phone, and also you provide a user with some kind of, I don't know, maybe web portal, and on this web portal you also provide user with an ability to edit these contacts, you can easily query all new entities which were inserted or updated from other source by simply saying, please give me all entities with version greater than this one. In this case, as I said, you will obtain all entities which were inserted or updated after like your current one. So it's also kind of good approach to use it for offline synchronization. The next one, backend logic. If you want to customize your backend logic for your mobile services, you can use JavaScript and .NET. To be honest, if we talk about JavaScript, we talk about Node.JS, and mostly we will talk about Node.js here, but of course, if you're familiar with .NET, or if you prefer .NET most, then you can also use a .NET backend. It's really not a problem. It will produce like completely the same results. Not modulus. If we talk about not modulus that are already installed on a host machine, it will be request module, push module, console module, send grid module, for example, MS SQL module for connecting your mobile services with SQL Azure database, and of course, like one of my favorite is Azure module. Basically, Azure module is an Azure SDK. So it's not a problem for you to use Azure Mobile Services and manipulate your Azure resources at the same time. You can easily create an application. I don't know, for example, you can create some kind of lightweight version of Azure portal, which will run on mobile phone, which will, I don't know, for example, query you for your all virtual machines, and near to each virtual machine you will have like restart button. You can click this restart button from your phone, you will send this request to Azure Mobile Services. Azure Mobile Services will check your authentication and restart your virtual machine. It's very good scenario, and it also will work here, so why not? Custom API. Previously, we talked only about Azure Mobile Services in context of table API, and I said that we have a table in a SQL database, and we can perform create, read, update, and delete operation on this table. But what if we do not need this table interaction? Like I described in a previous scenario, what if I want just to send some request to Azure Mobile Services and said, for example, please restart this virtual machine and this virtual machine. So I do not need any table interaction here. So this is when a custom API comes into play. So first, it's a not table-based endpoints. We already talked about this. It can be accessible from GET, POST, PUT, PATCH, and DELETE request. For Node.js logic, it's scripts like table endpoints. So basically, the idea of creating table endpoints for create, read, and so on operation are always the same as for creating this custom API. Of course, there are some differences, but basically, you can say that for 90% they are the same. And as we said, you can expose any functionality you want using this custom API. And here comes another interesting scenario about file storage. Let's say that your user wants to store some kind of pictures, or maybe avatars, or maybe some other icons, and so on and so on. As you may know, it's not a good idea to use these static images in your SQL database, because you know, like it's really hard for me to introduce or to imagine some scenario when it will be really so desperately needed. And of course, if we talk about Azure, Azure has like a dedicated service for storing your files. It's called Azure Blob Storage. And of course, if we talk about images or maybe some kind of, I don't know, audio or video files, you will prefer to store this file in Azure Blob Storage. Another good reason is that Azure Blob Storage will be much more cheaper. It will be extremely cheaper if we compare it to our SQL database. And let's imagine this kind of scenario that our user wants to store some image in blob storage. What we can do in this case? First, we can create a custom API, and user will call this API and ask for shared access signature. Basically, this shared access signature stuff, it's like a pre-authenticated URL with expiration time. And we can set, okay, you want to upload your image, here is an URL for you, it will expire like, I don't know, in 5 minutes or something like this, so you have like 5 minutes to upload your image. User will obtain this URL, and after this, he needs just to perform a post request to this URL. So basically, this URL contains everything for authenticating this user against our Azure Blob Storage. And the only thing we need is to provide like our image content. And that's all. We upload this image to our blob directly, and after this, in database, we will store only URL for this image. Another good point in this scenario is that we do not need to send this image to our API. We send this image directly to our blob service. So that's why now our API do not have this a lot of unnecessary inbound traffic. It will generate only shared access signature and returns it to our user. And of course, as I already said, blob storage costs less, and blob storage was like created for storing binary data. So I will highly recommend you to use this scenario and this approach for working with Azure Mobile Services and all other services in Azure. Now let's talk a little bit more about push notifications. If we talk about regular push notification flow, you should be already familiar with this flow. First thing you need to do is to register the push notification with push notification service. And you need to obtain for each device this unique device ID. And you need to send this unique device ID to your mobile services. After this, if you decide to send your push notifications through your devices to your clients, your mobile services should iterate through all these device IDs, and for each device ID, call for appropriate push notification provider. For example, for Android, it should call to Google push notification service. For iPhone, our mobile service should call for Apple notification service, and so on and so on and so on. And each notification service will deliver this notification through our client. Of course, we need to understand that in any case, push notifications, it's kind of not, they do not guarantee the delivery of this message, but basically it should work if everything is okay. But it's not a good idea to use this approach if we talk about sending like, I don't know, 1 million notifications, because as I said, we need to iterate through all these client IDs, and for each client ID we need to perform this dedicated request. And for example, if we have like 1 million users and we introduce like a new version of our application, or I don't know, maybe there are some specials in our application market, some, I don't know, promotions or some similar stuff, and we need to inform all our users about it, it will be not a good idea to use the regular push notification flow. In this case, I will recommend you to use another approach. It calls notification hubs. Basically, notification hubs, it's kind of another service. it's not really part of Azure Mobile Services. It's like a separate service, but if you will use them with Azure Mobile Services, you will have like a lot of benefits. For example, it's extremely scalable, and it supports a lot of platforms like iOS, Android, Kindle, Windows Phone, Windows Store, and so on. But what is like the hidden feature in this case? There are two of them. The first one is tags. For example, let's say that I have my application, I create my new application, and it's kind of, I don't know, maybe news portal or something like this. And for each user, I can say that he can customize which news feed he wants to read. For example, the first user will say, I want to read news only about sport, and the second one will say, I want to read news only about, I don't know, weather, and the third one will come and say, I want to have both sport and weather. And for each user, for each device ID, you can create this tag, and you can label this tag. You can label each device ID with this tag. And in this case, you will have tag like weather, and underneath this tag, you will have like, I don't know, 100 different devices or 1,000 different devices. And you are able to send your push notification not directly to device ID. You are able to send this push notification to tag. And this tag will be responsible for distributing all these notifications through all devices. And the second given feature which also fits in this scenario is templates. So if we talk about different notification services, we understand that, for example, Microsoft notification service prefer mostly some kind of XML format for notifications. Google notification service prefer more JSON format, and so on and so on. So basically, each notification service wants from you to create a notification in its kind of own format. But you can configure templates for transforming your base entity to each to dedicated entity for each push notification service. For example, I can say that please take like this field from my JSON and map it to this field in a JSON file, which will be sent to Google notification service. In this case, I need to configure these templates only once, and after that, I need to mark each device with one or several tags. And when I need to send a new notification, for example, I have like special promotions for all users till the end of the day. I will create only one message, and if I have tag like all users, I will create only the single message, and I will perform only one request to notification hub, and give this only one message notification hub, and said, please distribute this message through all users. And I'm done. After that, all magic behind the scene will be performed by notification hub service. So it's really kind of good stuff, and basically it's like my favorite two unique features, tags and templates. And of course, you have a lot of SDKs for notification hub for .NET, Java, Node.js, and also, if you do not prefer to use this SDK provided from Microsoft, Or if you do not have this SDK for your favorite platform, you can easily use directly REST API, because basically almost all Azure SDKs, it's just kind of wrappers against REST API. Now let's talk a little bit more about authorization and authentication process in our Azure Mobile Services. I want to describe which privileges you can use to manage access levels for your users. We will start from the middle. It's everyone. It's kind of a simplest way. So if you said that for this action, everyone can access it, it will be like anonymous access, and I do not need anything. I can just create this. If it's a GET request, I can create it with my browser. If it's kind of another request, I can create it with any other tool or from any platform. So basically, everyone is allowed access for anonymous users. The next one is application key required. If we talk about Azure Mobile Services, we always have two different keys. The first one called application key, and the second one calls master key or admin key. So this security level, application key required, it will wait for an appropriate application key in appropriate request header. And you can use this application key required method to ensure, for example, that each person who tries to access your API, for example, download your application from some kind of valid source or something like this. The next one is authenticated users. We already talked a little bit about integration with identity providers like Facebook, like Google ID, Twitter, and Microsoft account, for example. If we use this level authenticated user, then our user should pass authentication check against one of these providers. And the last one is admins and other scripts. We need to provide master key for pass this authentication level, or we need to call this method like directly from other scripts inside our Azure Mobile Services. In all other cases, we will obtain like unauthorized response. And on a server side, in Azure Mobile Services, we can also use this user object in each request for tables, for APIs, and so on. And our user object has several properties. For example, it has property called level, which described our current requests came from admin, from authenticated user, or from anonymous user. We also have user ID. It's like ID for provider in which user pass our authentication, or undefined. And also we can ask for get identities. We can call for get identities method in our user object and obtain like user ID, like access token for querying our authentication provider, and some other basic user information like name, email, pictures, and so on and so on and so on. Now let's talk a little bit more about scheduler. If we talk about scheduler jobs, I already said that our scheduler jobs can be can execute scripts. So basically, we create our scheduled jobs like a regular Node.js script. In this case, we can do really almost everything. So basically, if we can achieve this task using Node.js, we can easily create this script using Node.js and use it in our scheduler. We can run this script on a schedule. Also, we can run this script on demand. And it's kind of a very good way for processing your backend data and backend jobs. I will introduce one scenario from one of my projects. For example, we create like a new feature for our users, and we said, now you can import your data using, for example, XLS files or CSV files or some other, I don't know, XML files. It's not important here. And we upload this file to storage, as I described previous on this presentation. And after that, when this upload is completed, I run in an on-demand way my script on Azure Mobile Services side and said, please take this file. I sent this URL to our script, and I said, please take this file and please process this data and populate like my personal tables with this data. And it works really well. And of course, the length and the frequency of our scheduled jobs also depends on mobile service pricing plan. Here at the last slide, I want to show some links for Azure resources. So basically, it's Azure portal, azure.microsoft.com. You can obtain a lot of documentations at this portal. Also, you can obtain a free trial account for Azure. And if we talk about mobile services, it's also kind of good point. For some reason, I skip it, but I will say it right now. You have a free pricing plan for Azure Mobile Services. So if you want to start developing your application right now, you can use trial, and after that you can continue using free pricing plan for Azure Mobile Services. It's also very good stuff. Microsoft will of course limit you a little bit on CPU level. Microsoft will also limit your inbound traffic and total amount of requests to your API per month. But for example, if we talk about free pricing plan, Microsoft will limit you to 500,000 requests per month. Basically, it's really like a huge amount of requests, and even if you run your application in production, and for now you have not a lot of users, you can still using this free pricing plan even for productions. And the second link is about mobile services documentation. You can find a lot of videos, tutorials, and all other learning information here. And as I already described, Microsoft gives you this SDK for Azure Mobile Services, and if you want to go deeper in the source code of this SDK, you can easily find it on GitHub. And if you even want to contribute somehow in this SDK, you can easily fork this repository on GitHub, contribute something, create a push request. Why not? Microsoft is open-minded, and they will give you an ability to contribute to all SDKs. And before we will go to see some live demos, I also want to show you this slide. It's about Microsoft and Microsoft open source projects and technologies in Central and Eastern Europe. So basically, we have this group on the Facebook, and also on the Facebook, in events section for this group, we have a lot of events which we want to host in the nearest time. For example, in the nearest time, we also host a series of webinars about developing your Node.js websites also on Azure. Also, we have a Twitter account, and we have a website, www.openness@cee.com. And in case you have some suggestions, for example, you want to suggest a very interesting topic for a webinar, you can easily write an email to mswebinars@microsoft.com. And in this case, Microsoft will be able to find some speakers and trainers and host this webinar. Why not?
Okay, so I hope you are able to see my screen now, and I want to start with Azure.com web portal. So basically it's like your main entry point inside Azure world, because here you can find a lot of stuff like documentation, pricing, downloads, marketplace, and so on and so on. I want to demonstrate this free trial button, so everyone able to request a free trial account, you will obtain $200 for the 30 days period, and basically you will obtain all this stuff without any commitments or without any like additional payment charges and so on and so on. So if you want to try it, just go here, click try it now, and that's all. After 30 days trial period, you will be able to switch, for example, to pay-as-you-go payment model. In this case, this pricing area will be also very interesting for you. For example, today we are talking a lot about mobile services. So here I will demonstrate you the exact prices. Basically, Microsoft provides you with like 3 different pricing tiers. It's a free one, it's basic and standard. The difference is in price, and also the other difference is about amount of resources which you have for each pricing plan. But you can read all this stuff by your own. So now we have this portal button here. Let's go to management portal. Here we need to pass an authentication using our Live ID. Okay. Sign in. And here you will be able to see my Azure portal. Now it will load all resources. So as far as you can see, I have created like my first Azure Mobile Service, but let's create a new one. So I will repeat, I need to click this new button here, then Mobile Services, create. The first thing I need to provide a URL. So let's say Boyko, something like this. This URL should be unique across all Microsoft data centers. Also, I need to provide a database. I can use an existing database for my mobile service. I can create a free database for a single subscription, I can have only one free database, but hey, like 20 megabytes database, and it's free, and also Microsoft have like a free pricing tier for your mobile services. So it's kind of good option to start. Basically, free, and free. Everything is free for the testing purposes, for the development purposes. So I think it's kind of a good statement. But I want to create a new SQL database instance. Also, I need to choose a region for my mobile service. As far as I am from Ukraine, my favorite region is North Europe. Also, the backend. Microsoft have like two options here, JavaScript and .NET. Basically, JavaScript it's about Node.js, .NET it's about Web API, but we will choose JavaScript. Also, we can choose to configure advanced push settings, but let's skip it for now. Let's go next. Here I have like my database name, and I can create just kind of a database in the middle of the nowhere. I need also to create a database server. So as you can see, I have a lot of database servers, but if you will go here for the first time, you will be able to create only the new one, because just out of the box you have zero SQL Server. So I will provide an administrator name and administrator password here. Now the other fancy stuff is that your database server, it's like very high recommended to place them in the same region as your mobile service. Just because it's obvious, if you will have your API and database in the same data center, it will work much more faster than if it was like two different data centers, like one, for example, in Ireland and the second one somewhere in Japan. And also we can configure advanced database settings, but also let's skip it for now and click complete button. So now we just need to wait a little bit until Azure will provision us with all required resources. Basically now Azure will create like a SQL database server, spin up a new database, also spin up a new Azure Mobile Service with Node.js backend. So let's try to relax and wait a little bit. And I have this mobile service, so let's go inside and see what we have here. So inside my new mobile service on this first tab, I can see that hello, your mobile service was created. Okay, thank you. And now like the most easy way how can I start with Azure Mobile Services, I can download already like pre-configured created application example, and I can download this example for Windows platform, iOS, Android, HTML, JavaScript, Xamarin, and PhoneGap. So as you can see here inside Get Started, I have created new PhoneGap app, and here I have download button, and after that I will be able to download like an example application, and it will already be connected to my mobile services. But let's go to see what we have in other tabs. So here, dashboard. Here I can see a lot of metrics, and basically it's like resource usages metrics, and I can see my API calls, data out, HTTP server errors, SQL CPU load, and so on and so on. Of course, for now we have all zeros just because we just created this service and we did not submit any requests and so on and so on. So that's why now we have zeros, but either way, after we will start using it, we will start to see some more fancy numbers here. Let's scroll a little bit below. Here we have mobile service URL. So basically this is a URL of our mobile service, and we need to submit or send all requests against this URL. Of course, we just the URL itself, it's not very useful for us. Also, we have this manage keys button here. If we will click here, we have both application key and master key. We can use application key to authenticate any user which basically use our own application, or we can use a master key just to explain to mobile service that this request came from admin user. So of course this is kind of hint for you that you can easily share your application key, but basically your master key should be as much private as possible. And of course you have to independently generate buttons. You can click and, for example, said, okay, for example, my master key was stolen, so let's change it. Okay. And now, as you can see, I have completely new master key with the same application key. So it's just so easy. If I scroll down a little bit, I can also see in more details my usage. So basically, Azure Mobile Service creates using a free pricing tier. So that's why we have these limitations here. We have this limitation for API calls, for active devices, like 500 devices per day. We have this limitation for data outbound traffic, and also limitation for SQL database size. But of course, when we will switch to a basic or standard pricing tier, we will have much bigger limits. Okay, let's go to data. As far as you can see, we have no tables here, but basically inside data tab, we will be able to create our tables, and of course, not just tables, but tables APIs. Here, inside API tab, we are able to do pretty much the same. We are able to create a new custom APIs, and of course we can create as much APIs as we need. If we go to the scheduler tab, we can create here a new schedule chart and run the job on some kind of particular schedule. So everything about scheduler goes here. Inside push tab, we are able to work with our push notifications. So as you can see, we automatically were attached to notification tab. And also, if we scroll a little bit below, we are able to use like a regular push notification services provided by Microsoft. For example, they have like a Windows application notification service. It's about Windows tablets, and Windows Phone notifications server. It's about Windows Phone. Also, you are able to attach Apple push notification and Google push notification settings. Just provide like the required configuration here, and you're done. You're able to start only like in several minutes after that. Inside identity tab, you are able to configure your identity providers. And as soon as you configure at least one of them, you are able to authenticate your users also against this identity provider. For example, Microsoft account is the same as Live ID, so it's the same like we use to authenticate ourselves on Azure portal, or for example, inside Outlook.com webmail. Here we also have Facebook, Twitter, Google, and Windows Azure Active Directory. Also, I want to mention here when we talk about Windows Azure Active Directory, it's not the same as regular Windows Server Active Directory. It's like a different cloud-based service. So just to give you like a quick overview, do not mess with these two different services, Windows Server Active Directory and Windows Azure Active Directory. Let's go next, Configure tab. Here we are able to adjust some configuration properties of our mobile service. For example, we can point our mobile service to another database or another SQL server. Of course, if we want to work with source control, we are able to use like a git URL, and we are able to download and upload all our files related to Azure Mobile Service using just regular git pull and push commands. Also, we can use dynamic schema here. Basically, dynamic schema is on by default, and if you have dynamic schema enabled, it will work in this way. Let's say that you want to, for example, create a new record inside some of your tables, but you want to create these new records with some like additional properties or field which for now you do not have inside your database. In this case, if you have dynamic schema on, all these columns inside your tables will be automatically created to satisfy like your needs, and they will be created in a way that your requests will be processed. So basically, if you have 2 or 3 or like 10 and so on additional new properties, it will work easily. Here also you are able to configure like hybrid connections. Also, you are able here to configure cross-origin resource sharing. The basic idea of this stuff is that now you are able to create not only mobile applications, but also you are able to create even kind of web applications based on Azure Mobile Services. So if you are familiar with this stuff like cross-origin resource sharing, basically it's one of the security restrictions of JavaScript engine inside any browser. And the main idea of this restriction is that you are unable to submit a request to another domain name until you configure cross-origin resource sharing. Also, you are able to use developer analytics. Also, you are able to provide some custom application settings, and or you are able to use connection strings settings to provide connection strings for your database or any other external resources. Also, you are able to configure monitoring here. So for example, you can say that, okay, I have these endpoints inside my mobile services. Please try to ping those endpoints like every 5 minutes. And if someone is going really not good, for example, if we're not obtaining a response like HTTP OK, then Azure will send you like an email, it will raise an alert flags, and so on and so on. So in this way you will be able to understand that you have some issues with your application as soon as possible. Okay, let's go to Scale tab, and here basically you are able to switch your pricing tier from free to basic or standard. And let's switch to basic, for example. After that, after you will switch from free pricing plan, you will be able to configure like your auto scaling engine. For now, you are able to use autoscaler in two different modes. You are able to use autoscaling on like a schedule basis. So for example, let's spin up a new instance every morning and let's shut down this additional instance like every evening, because mostly my users use my application like from 8 a.m. to 8 p.m. or something like this. And the next way, you are able to configure your auto-scaling based on API calls. So in this case, the example will be a little bit different. Let's say that really a lot of users start using your application and you just have no resources to process all API calls. Basically, you do not have resources to process all requests. So that's why you will create a new instance, just because in this way you will have, like, for example, you start from one instance and after that you create another one. So now you have like twice more amount of power to process all requests coming from your users. And also here you have a link to manage scale for your database, but because SQL Azure is kind of another independent service, so that's why to work with SQL Azure databases, you need to go to a separate area on this portal. And the last tab is logs. So basically here you will be able to see all logs. You are able to manually put your logs here, for example, using just regular console.log statement, or if some unhandled exception will rise inside your application, this exception will be also automatically logged here, and you will be able to go here and try to find out what's going wrong and basically why it's going wrong. Okay, so for now I give you like the brief overview of Azure Mobile Service web portal. We'll talk in more details about data, API, and so on and so on and so on our next webinars.